Hello, so this is just a short video recording as a commentary on the second lab exercises on the solutions. So I'm just going to go over some of the solutions, make a little commentary on the code. Okay, so the first question was string manipulation. We're given a list of the first names, given a list of the second names, and the aim is to create usernames, as you might do if you're working for a company and you had a generic way of creating computer usernames, and you want to combine the first name with the second name and then convert everything to lowercase. Okay, so we can kind of see the plan from the structure. We need to kind of loop over both elements. In lectures, then we have to convert all the strings to lowercase and then combine them together. So here's a link to some string functions, which I should pull out. And you can look here, there's wants to join, make trans, and here there's a command to convert a string to a lowercase. So that's what we're going to do. So the plan, the thing is, I need to sort of loop over the first name, second name, and then add them together. So that's the kind of plan of the code. Here's the actual code I wrote. So I've actually written two versions of the solutions, partly because the second solution is a bit more fancy. So here's my string. In my first solution, I loop over the first names. I then have a counter, and the counter sort of is an integer, and on the first time it's count 0, so that gives me Wilson. Then I run the lower thing, and okay, so this count keeps track of the second name you're on. The plus concatenates the two strings together. Then the dot lower converts it, the string, everything to lowercase, all the characters. So the first round on the root we get William plus Wilson, and then the dot lower converts the uppercase to lowercase. And then the next time round count as 1. That means the second name is pointing at Davis. And that's a perfectly valid solution. However, you can do things a bit more fancy. This is the way I kind of used to do it, but now, because I've done this so many times, I use a thing called zip, and this means that F name and L name, when I do this zip thing, it'll loop through the first name list and the second name list. Then I just need to concatenate together. This creates a string. First part is F name, and the second part is L name, and then I call the lower. Okay, so let's run it. Okay, so and both the top ones are here, so both solutions are perfectly fine. So doing it like that is okay. This is a bit nicer, but it's only saved you a couple of characters. Okay, so question 2. The idea was to count words. So we have some text, and what we want is to count the number of words. So we've discussed some of the kind of string formatting type things. So to count the words, one of the things we need to do is to split the string up into separate words, and we've seen in the past there's a split function to do that. And then what I suggested to use was a kind of dictionary structure. So let's clear the console. Let's clear the console. Move on to Q2. So here's the text. And then one of the things about this, we're going to count the number of words because of the comma here and the dot here. This means that some of these things, it'll the way that the code originally worked, it'll count night dot as a separate entity. So what I've done, the first thing is replace the commas and the dots, get rid of all the punctuation, and then I'm just left for words. So the name of this game is just count the number of words in the string. So the first thing I do is replace all the punctuation. Then I use this split, and as we discussed in the past, the split will convert the text into a string, into a list containing the word separated by spaces. Then I need to count it, and the sort of natural way to do that is a dictionary. So I've got store here equals dict, creates an empty dictionary. And the thing is that if I start assigning the way that Python works, if I try and, so this dictionary store is going to count the number of words. So I'm going to have a dictionary sort I, and then when it loops through answer, it's going to count the number of words. Unfortunately, for this to work, I have to first create the store in terms of words, set the counter to 0. So I pass through the loop once, and then when I've done that, I set all the words in the dictionary to 0, and then I pass through the loop again, and this time I actually, because this store license by word is 0, it actually counts the words, and at the end I loop over it and print it out. Okay, so let's run it. Okay, so here I've got the correct thing. So I've got to bomb, bomb there, bomb again. I think we can move over. Okay, so the bomb comes 3 times. That seems to work okay. And it's printed the output. Perhaps it's more interesting to look at store. So store is the dictionary, and you can see this data structure here. This means it's a dictionary, so I turns once. So the string I is being seen once. Watched is a string 1. So let's actually, if we print store, okay. Okay, we did the live coding was on. More ham-fisted. Let's get the syntax right. Okay, fine, I got it right. So I print store, and actually it's kind of referenced by I, which is from the top, and it tells it sees it once. And at the end I loop over it. Okay, so this is a solution. It's a bit ugly actually to do this step here, where I loop over the all the separate words, set this to 0. I could, now that we know about exception handling, I could have used some kind of exception handling to test whether store existed, and then I could have set it to 0. If we look at answer, so here, so it's very good to look in the variable tool to see what is going to happen. So here we have answer as text equals split, splits up the text into a string, and the first element is I watched a great film. So it's broken up that text into a list, tells you the type, a list, with each element is a word. Okay. Variables. So that's not question 3. Yeah, so the dictionary is a very powerful way of, if you want to do kind of manipulation of strings, like counting. Okay, so this question, so question 3 was the next question. So into solution. So what I'm asking you to do is to write a kind of like memory of your exercises. So every time you run the code, it inputs the number of press-ups, sit-ups, and jogging, and then it writes it to a file and puts a timestamp at the top. Okay, so I just reran this today. So we have timestamp, number of press-ups, sit-ups, and jogging, another exercise session. Okay, let's go to Q3. Let's just run the code. So here I'm asked to input the parameters, so I input it here. Let's do 2, 0, 3. I've looked at my file. What it's done is put a timestamp, put in the number of press-ups 2, sit-ups 0 and 3, and then it has the exercise done earlier, well, the fake exercise that I did earlier in the evening. So I gave you this code. This will input the number of press-ups, sit-ups. Then I'm opening it, the file, and this A here means append. And what this means is, it means when you write the text, it goes to the bottom. So when you run it, it tells you to start writing at this point. That's what this A means, append. And if you want to start from the beginning of the completely fresh file, you put a W there. Okay. And then to do the timestamp, I have import time, and I think I got this from my current web page. It was also in one of the LinkedIn videos. So I have local time, time.ascii time, and then there's commands to create a timestamp. And then the way you write out text file is file.1 is opened. Then you do file.1 write, and it writes a string. And I have to write a string time plus local time, which is a string, and plus this thing is a new line character, which you have to do quite a lot in the way this is done. Then press ups, same thing, plus press up. This concatenates the press up plus the variable press up plus the new line. Same thing here, string for sit up, concatenates with sit up the string plus a new line. And then once we've written it all out, we close the file. And say, and this is what we get. So it writes a timestamp out, writes press up, and the number 2 you've entered, sit up 0, jog 3. Okay, and in the real world, well, in the more advanced thing, we'd actually put in some exception handling just to check that something's correctly been entered. And yeah. Okay, so this is kind of a slight that is starting to do as far as we get in statistical analysis of Python. So question 4, the Guardian makes data sets available, and they have data sets of oil spills on the North Sea, and there's a spreadsheet which you download from the Guardian site, and the idea was to compute the mean and sum of the leakage rate, the amount of oil lost over the instance, and then there's a column in the spreadsheet that classifies the spill as either significant or minor, and you're asked to write some code to determine whether the oil spill was significant or minor, and compute the amount of significant and minor spills. Okay, so let's look at the let's look at trying to look at the array. Okay, so this is the spreadsheet. Okay, so here are the commas. So there's information, and I put out what the instant significant, and then there's the leak size in kilograms. Yeah, and the final thing is severity, how serious it is. So here's my solution. So I mean, this was, I showed a similar example in lectures. I had some code to open a comma separated list. So this means the columns are separated by commas, and there's a bunch of rows. Okay, so I have some code. I open up the comma separated file delimiter. This thing skips the headers. Then I use a string. Sorry, I use a list to store the mass. I have to make sure I understand what row it is, and I append it. This means it goes to the end of the row. And I found it's row 4. Then I find row 6. I test to see if it sees the phrase significant. If so, then I add 1 to my counter for significance. So I start off with significant 0, minor significance, And then row 6 I see is the one that's significant or minor. If row 6 is significant, I add 1. Else, if it's minor, I add 1 to the minor counter. Okay, so, and then I just write out the number of significant spills, the number of minor spills, and then I can count the percentage of significant spills just by adding together the count sig plus count minor should be the total number of spills, and then the multiply by 100 times by count sig, and that'll give me the percentage of significant spills. Okay, and the way I've done, which is a kind of common pattern, I have the mass. I find the mass at each. So this this loop here loops over every row, and the mass as I determined is in the 4th row. I convert it into a floating point number because it's a number. It's read in as a string. So I start the loop. The mass is empty. As it loops through the comma separated file, it determines the 4th column, and then it adds it to the end of mass. And then once I have that, so you have to actually determine the sum and the mean. So once I have it in the mass list, I can just loop over the mass list, add up all the numbers, and that'll give me the mass. And then if I divide by the number of elements in the list, the mass, that'll give me the mean or the average. Okay, so let's remove all the variables. Let's clear the console. Okay, and let's run the code. Okay. So that gives us the total mass of the spills in kilograms. And notice here I kept in the units correctly, and the mass of the spill. And then this statement here is kind of jargon for just giving me 2 decimal places. So I just cleaned up the format a little bit. And so we can see here, what I said before is mass ends up as a list, and you can see there are numbers here. It's 40, 45, 94.8, 4,600. So it's a list of everything it finds in row square brackets 4.